Okay, we have here another interesting integral from the CalTech Math Meet 2025, number 11. We have the integral from 0 to 3 halves, floor function, x plus floor function 2x dx. Okay, I like this one. It's kind of different having 3 halves here. We're used to having integrals from 0 to 1 or 0 to 2025, so it's a little different. It seems like I've had a lot of integrals with the floor function lately. There's always kind of a choice. Well, maybe not always. Like if it was just floor x, then maybe there's no choice. But the choice is, do we want to do a u substitution or not? I actually did it both ways on paper. The u substitution took up less paper, I can tell you that, but I don't know if less paper really means faster or if it even matters. So I think what I'll choose to do is skip the u substitution and split this up into we'll split it into 3 integrals. Because what's going to work nice with this inner part is if we split it on halves. So we can do 0 to 1 half, and then our second integral we'll do like 1 half to 1, and then for our last integral we'll do 1 to 3 halves. So for this first integral, we could probably do it like all in one step, but I'm going to do it out just so we can see what's happening. So I'm just focused on simplifying this piece. If the upper bound's 1 half and you plug it in here, it means that at the upper limit we're going to be at most 1, but with integrals we don't really consider the actual bound. So it's really everything here is going to get rounded down to 0. It's not going to quite reach 1. And so we'll just write this as x plus 0 here. For the next one, same kind of thing. We won't reduce the x yet. But floor, if you go from, like when you plug in 1 half, it's going to be at 1. If you plug in 1, it's going to be at 2. But in that region, the floor is always going to round us down to 1 here. And then for the last one, same kind of business. You plug a 3 halves in, it's going to be at 3. You plug a 1 in, it's going to be at 2. So we're between 2 and 3. Floor is going to round us down to 2. But then from here, we still have the floor function, but we know our x values. In each case, we know exactly where our x values are going to lie. Like in this first one, if 0 is nothing. If our x values are between 0 and 1 half and we're within the floor, everything is going to get rounded down to 0. So the first integral here just goes away. That's a 0. For the next one, our x values are between 1/2 and 1. So that means here we're going to be between 3 halves and 2. The floor is going to round it down to 1. So this, we can just kind of get rid of this and think of this as a 1. And here at the lower bound, we're at 1. So what's going to happen is the floor is going to round everything down to a 3. So this last integral is just going to be a 3. So to clean it up, we're just integrating 1 from half to 1. And over here, we're integrating 3 from 1 to 3 halves. So we got 2 very simple integrals. We got x from half to 1, and we've got 3x from 1 to 3 halves. Plug everything in. For this one here, it's going to be 1 minus 1 half. Here, I'll kind of factor the 3 out, so it's going to be 3 halves minus 1. Putting all this together, here we have a half, and here we have a half, so this is going to be 1 half plus 3 halves. And so for my final solution on this, we just get a 2. Okay, there you go. Quick one from CalTech Math Meet 2025. Thanks everyone for watching. Have a good day.